right, before we can go on and talk about informal proofs, we're going to need to talk about the notation of logical statements. We want to be very precise. English has a tendency of not being very precise, and so we want to have a way of sort of representing very clearly the things that we're talking about or doing. And so let's start with just a statement, a logical statement. What would that be? We would usually use a letter to represent that. So maybe A or B or C. In this case, I'm going to choose S because it's a statement. So here is the value, the statement S. That S could represent just about anything, right? It could be the earth is flat. It could be Tupac is alive. It could be I never make mistakes, right? All of these are statements that have a value. Now for right now, we're just going to consider the possible values of true or false. Those statements are either true or they're false. There is ample evidence to suggest that all three of the things I just said have a value of false. But for right now, we would say the value could be true or false. So similar to a statement, you can actually negate a statement. And so we would use this symbol to show the negation of S. Although I will say your book actually just does the word not for right now. I'm okay with that. So not S is just the opposite of S. Except I shouldn't say opposite. What it really means is it is not true that S. That English phrasing is helpful when you're trying to understand what's going on. So for instance, the earth is flat. It is not true that the earth is flat. We might just say in regular English, the earth is not flat, right? So since the statement is the earth is flat, which has the value of false, then the earth is not flat would have the value of true, right? We're just negating the value. So if it was true before, now it's false. If it was false before, now it's true. Tupac is not alive. Here's where it sort of gets interesting, is that third one. I never make mistakes. If I'm thinking in my head the opposite of, you might think that the negation of that statement is I always make mistakes. But that's not true. Negation just means it is not true that I never make a mistake, right? Which means that if I just make one mistake, the negation is true. Opposite kind of has a little bit of an ambiguous meaning. But negation, it is not true that whatever the statement is. So now that we have statements, we may want to combine those statements together to make a more complex compound statement. There's a couple different ways of doing that. The two most common are called conjunction and disjunction. So conjunction is if I have a statement A and I have a statement B, I could talk about the statement, compound statement A and B. So A can either have a value of true or false. B could have either have a value of true or false, which gives us four different possibilities. A could be true and B could be true. A could be true and B could be false. A could be false and B could be true. And A could be false and B could be false, right? Every possible combination of those two things. Now for and, A and B to be true, that compound statement to be true, and requires that both A and B be true. And you can kind of think about this just in English, right? If I tell my son, hey, we can have ice cream tonight so long as you do your homework and you clean your room. Well, if he does his homework and he cleans his room, he gets ice cream. Easy. If he does his homework but he doesn't clean his room, he doesn't get ice cream. I said and, he had to do both. If he doesn't do his homework but he does clean his room, he still doesn't get ice cream. And obviously if he doesn't do anything, he doesn't get ice cream. So the value of that compound statement is only true when both A and B are true, and false in every other case. Disjunction works in a very similar way, except that instead of associating it with the word and, we're going to associate it with the word or. So here, same thing, I've got two statements, A, B, and then I have that compound, more complex statement, A or B. Same as before, A and B can have four different possible combinations. True and true, true and false, false and true, false and false. So going back to my analogy about ice cream, right? If I say to my son, hey, we can have ice cream tonight, so long as you either, well, so long as you make your bed or clean your room. I've changed the condition, right? I've changed the way I've combined those two things. And so now if he does his homework and he cleans his room, he gets ice cream, right? If he does his homework but doesn't get around to cleaning his room, well, I said or. He only had to do one, so he still gets ice cream. In this case, if he doesn't do his homework but he does clean his room, he still gets ice cream. He did at least something, right? The only time he will not get ice cream is if he doesn't do anything. If he doesn't do anything, then he doesn't get ice cream, right? The idea for or is that or will be true so long as one, either, or both of the statements that are combined together are true. The only time or is ever false is when both of the statements are false. So more than likely, I guess in 3/4 of these situations, we're going to head across the street to the ampersand and get some, honeycomb or whatever. Another common way of combining statements together into a more complex, compound sort of a statement is by using a conditional expression. If you've taken a programming class, you're probably very familiar with these. If I've got two statements A and B, I could say, if A, then B, right? In this case, A and B are sort of playing sort of specific roles. A becomes what we call the antecedent, and B, the thing after the then, becomes the consequent. Those two words, may not have a whole lot of meaning to you, but when I think of antecedents, the first thing that comes to mind is a class in behavioral psychology that I had back in college, right? The idea that for a lot of our behaviors, there's antecedents that lead to it. So maybe you tend to snack while watching television. Something you might do is not watch television or change the way in which you watch television, and that might reduce your snacking. Some people who, smoke, for instance, they might, get into the car, and they often smoke in the car, and so the act of driving becomes an antecedent for the behavior of smoking. Now, this isn't a behavioral psychology class, but it at least gives us sort of a framework to think about this, right? So if I were to say something like, if I stay up late, then I will snack on cheese, right? Now, that statement has sort of an antecedent, right? If I stay up late, it has a consequent. If I do stay up late, then I'm saying that I'm making the statement that I will snack on cheese. So in other words, if A happens, my claim is that B is going to happen. There's a couple different ways of saying this. Sometimes we'll say something like A implies B, right? So staying up late implies snacking on cheese. I might say that A is a sufficient condition for B. Sufficient condition means that it's in and of itself sufficient to cause B. So if I am up late, doesn't matter what else is going on, I will snack on cheese. That is my claim, my statement, right? So A is a sufficient condition for B. This one kind of gets a little bit tricky, but it is sometimes used, or is often used, which is to say that B is a necessary condition for A. That doesn't mean that the B alone having existed implies A, right? Just because A implies B does not mean that B implies A. It doesn't go back and forth. But what it means is that, B must be there in order for A to be true. So in other words, if I'm snacking on cheese is something that is necessary for the act of me staying up late. The behavioral psychology part of this might be making this analogy go a little bit stretched, but that's fine. But those are sort of different ways of expressing the same thing. The truth table that results from this might not make a ton of sense to you at first. The first two should. If it is true that I am up past midnight and you find me snacking on cheddar, that means that this statement is true. If I stay up late, I will snack on cheese. If I'm staying up late and I am not snacking on cheese, then this statement is false. Because I made a claim, and that claim didn't come true, right? I said, if I stay up late, I will snack on cheese. That didn't happen. So my statement is false. The next two are the ones that are going to be a little bit confusing, because in both of these cases, the antecedent is false. In other words, I didn't stay up late. So because the thing that I said would happen, like, so if this happens, then this other thing will happen, the first thing didn't happen. So it turns out that both of these are true, right? And it's true just because the thing that I claimed was never contradicted, right? I'm still telling you the truth. In this case, it happens to be like, okay, so what if I'm snacking on cheese, but it's the middle of the day? Well, that's perfectly fine, right? That doesn't contradict the idea that if I stay up late, I'll snack on cheese. I might snack on cheese at other times. Remember, B being true, B is a necessary condition for A, but not a sufficient condition for A. It doesn't mean that A will happen. It just means that B has to be present in order for A to happen. If I didn't snack on, if I'm not staying up late, it's the middle of the day, and I'm not snacking on cheese, that also doesn't contradict my statement, right? I didn't stay up late. So in this case, both of these things would be true just because the antecedent isn't true. Now there's a couple weird terms that kind of go along with this, but whether or not you'll actually need them is sort of here or there. But we can say that something is vacuously true whenever the antecedent is false. So in both those last examples, they were vacuously true. If horses were fish, they would swim faster than sharks. Is vacuously true. The antecedent is false. There's really no, whether or not they would be faster than sharks is somewhat irrelevant. There's no way we can test it, right? Your claim really can't be challenged. In the same way, we could say that something is trivially true, right? So whenever B is true, whenever the consequent is true, we would say that it's trivially true, right? So I could say something like, if horses were fish, then, I don't know, something that's incredibly true, right? The fact that the consequent was true doesn't mean that the antecedent was true, right? It's trivially true. It's like, yeah, it's like not kind of related, right? And so those two terms you may hear from time to time. Something is vacuously true if the antecedent is false, and something is trivially true if the consequent is true, whether or not the antecedent is actually true. While we're talking about different concepts, there's the idea of the converse of a statement. So in this case, if the statement is if A then B, the converse of that statement would be if B then A. Now there is no guarantee or even likelihood that the converse of a statement will be true just because the original statement was true. For instance, since we're talking about converse, shoes are coming to mind. If the shoes are made by Yeezy, then they are expensive. That statement is true, right? I think we can judge that. But that does not mean that if the shoes are expensive, then they're made by Yeezy, right? No guarantee of that. There's lots of expensive shoes that are made by other people that aren't superstar rappers, right? The idea is that the converse just reverses the two, but there's no guarantee that the converse is actually true. It could be though. You'd have to prove it. Now you probably know from English, there's actually lots of different ways of saying the exact same thing, but in slightly different ways. And so we would call these, at least in terms of our expressions, equivalent expressions or equivalent statements. And so there's a few of them around there. So for here, I have not A and B, or not A or B. These are similar but slightly different. And whenever you sort of distribute the not to these two things, kind of like you would with math and multiplication, you just have to switch the or and the and. So for instance, if I were to say that I am not wealthy and talented, well, what does that mean? It means that I am not wealthy or not talented. I've distributed the not to the A and the B, right? Your little distribution method. But in doing so, I had to switch the and to an or. And that makes sense, right? If I say that I'm not wealthy and talented, then that means that I could be one. I'm just not both. So I'm not wealthy or I'm not talented. Now I could be neither, and the or would also be okay with that, right? You can have both sides be true in an or. If I said that I was not wealthy or talented, right? Well, that's actually a little bit of a harsher criticism, isn't it? Because that's not even allowing me to have the one. Here I would say that I am not wealthy and I'm not talented. Right? The only way that and can be true is if both things are true. So I can't be wealthy or talented, which is another way, I guess, of expressing it. But you can find different ways of expressing that. And it is sort of mathematical using distribution or just thinking about things sort of logically with English. All right, just a couple more concepts before we finish. One is the idea of the contrapositive. So now this is just another equivalent expression, but it's sort of a specific one. So whenever you have a conditional in the form of if A, then B, right? If I stay up late, I will snack on cheese. Then the contrapositive of that statement is if not B, then not A. If you negate the two and then essentially do the converse, right? That's called the contrapositive. And it turns out the contrapositive is an equivalent expression. It has the exact same value. So this would be true. Going back to my behavioral psychology bit here, if I'm up late, I will eat cheese. If I'm not eating cheese, then I'm not up late. It's the exact same expression, right? If I'm not eating cheese, that means I can't be up late. If I am eating cheese, doesn't mean that I am up late, but that's not being claimed here, right? And so that's called the contrapositive. And although there are many other equivalent expressions we could talk about, this is the last one because it's kind of useful. And that's whenever you have one of these conditional statements, if A, then B, and you want to get rid of the conditional, right? You want to convert it into something that is a little bit more ands and ors and nots, right? Something you could, potentially, I don't know. You may find this useful in a proof from time to time. And so here's the idea. This statement is the exact same statement as not A or B. Notice there's no parentheses there. It's just the or. So going back to, again, behavioral psychology, this would be the same as saying, if I'm not up, I am either not up late or I'm eating cheese. That is an equivalent statement. It is true. If I say, if I'm up late, then I will eat cheese, then saying I'm not up late or I'm eating cheese expresses the exact same thing, but without the if then, just a not and an or. And so that might be useful as you're going through stuff to sort of make things work the way you want to in your proofs, which we'll get to later. But at this point, we've covered most of the basic notation you would need for making statements and sort of combining them in logical ways for this class.